You guys know I like 7-minute summaries, so today we're doing a 7-minute summary of the first chapter of the Introduction to Quantum Mechanics, third edition by Mr. David J. Griffiths. Let's take a look at the first chapter here. If you guys want to see a run through of all of the chapters for the first section of this book, check out my other video over here. The first chapter is the wave function. We have 6 different sections, 20 pages for the total chapter, page 3 to 20, so I guess 17 pages. We're going to try zooming through it. All right, let's zoom through, start at the first chapter, and see how it looks. Let me zoom in here. All right, 7-minute timer starting now. The wave function. Schrodinger equation. What are we looking at here? I guess just bolded words. Oh my god, there's lots of text. Okay, here's a bolded word. Wave function, which is this little symbol here, this little psi Greek letter. Schrodinger equation is also bolded, and there's a colon here, and they give us this. So I'm assuming this is the Schrodinger equation. It looks kind of insane, but we're just going to zoom through. We got a constant over here, Planck constant. Interesting. And that's the first section. First section is like 2 paragraphs, boom. Second section, the statistical interpretation. Looks like we have a picture here, particle constrained to move in a one dimension under influence of a specified force. This is a little cart. We got displacement x, mass m, force. And then we have here a typical wave function. The shaded area represents the probability of finding the particle between A and B. Cool. Here we got statistical interpretation in bold. We got this little psi symbol again, probability of finding a particle. Probability of finding the particle between A and B at time t. We got an integral here. We got psi. This is the wave function, which we saw before. Then we got another bolded word, indeterminacy, into quantum mechanics. Okay, we're going to zoom through. We have a list, 3 different points. The realist position, the orthodox position, the agnostic position. Then we have some more bolded words, hidden variable, Copenhagen interpretation, and that's about it for bold words. Okay, I think I'm gonna read these in some free time because I wonder why they're listing this, and I'm kind of curious what these 3 different positions are. 1 minute 40 done on the timer. Let's keep going. The collapse of the wave function, psi straight lines squared immediately after a measurement has found the particle at point C. Okay, what does this mean? We're going to keep going through. I just see this capital word Bell, Bell's discovery. This probably implies a person named Bell. I think I've heard of this gentleman before. Okay, no bolded words here. I'm just going to move through. Example 1.1, electron interference. We've got some scatter plots here. I'm assuming these are electrons hitting some kind of photosensitive screen. Interesting. So example. I guess there's no problem here. It's just an example. We'll read it later when we have the time. Section 1.3, probability. We got 6 sections, and I have 2 minutes, 30 seconds on the timer here. Okay. Probability, discrete variables. 1 person aged 14, 1 person 15, 16, 22, 24, 25. If we let n as a function of j represent the number of people of age j, then n of 14 equals 1. Okay, so they're just listing out how many people have a specific age. So we have age 25, 5 people of age 25. I see. Okay, histogram showing the number of people with age j, the example in section 1.31 right here. And then we got a sum. I'm not going to dive too deep into the sum. Question 1, answer. Question 2, answer. Question 3. I'm not going to read through these questions, but I guess they're talking about some kind of probability stuff. Here it looks like they're taking an average. What is the average or mean age? It is 21. In general, the average value j, and they give us this equation here. Nice. Question 5, what is the average of the squares of the ages? We got another equation here. We got a boxed equation here. In general, the average value of some function of j is given by, boom. So we have an important equation in a box. Then we have 2 different graphs here. I'm not going to look at these too deep. Some more equations and stuff with the letter j. We got this little sigma here, sigma letter. This is the variance, standard deviation. Some more equations. Taking the square root, the standard deviation itself can be written as, boom, another equation, and then we have something here. Okay, continuous variables. Let's go through, let's read this here. Probability that an individual chosen at random lies between x and x plus dx is this. Okay, we're going to keep going through. We got probability density here. Let me check the timer. 4 minutes, 25 seconds currently, and we have 7 minutes. Example 1.2. Okay, and our first problem for the distribution of ages in the example section 1.3.1, compare this thing j squared and this thing squared j, determine delta j. Okay, some problems. Problem 1.2, problem 1.3. First three problems of the chapter. Problem 3 looks cool. Consider the Gaussian distribution where a, capital A, lowercase a, and lambda are positive real constants. Use equation blank to determine a. Find this sketch graph. Okay. Normalization. Then we have a boxed equation over here. 5 minutes, 5 seconds on the timer. This uses psi, so I think we're back to quantum mechanics. We just took a little bit of a detour to cover probability. Probably it relates to this. And we got normalization. Cool equation right here. Another cool equation. Ooh, a lot of equations here. And QAD. When you see QAD, it normally means a proof is happening. So I think they start over here with some kind of proof. They get to a result. This equals 0. Whatever this means, QED. We're going to look at that later. Another problem, and now we have psi. Very interesting. We got some cool problems here. Another problem. Momentum. Section 1.5. Second last section. We're at 5 minutes, 43 seconds. Making great time. I know I'm not learning too much. This is a 7-minute summary. We're just going to sweep through, see what we can get. For particle in state psi, the expectation value of x is this. An interesting equation. And it's boxed, so it's important. Some more equations. No bolded. Oh, ensemble is bolded right here. It's okay. I'm just going to sweep through. Looks like another bolded equation, momentum. So I guess this is talking about momentum. We say the operator x represents position. The operator represents momentum. Cool, we got operators. 6 minutes, 23 seconds. Let's sweep through. Another interesting equation. Some more problems. A little wave with the gentleman waving something. Cool. The uncertainty principle. We got a boxed equation here. I'm assuming this means the uncertainty principle. Problem 1.9. And further problems on chapter 1. We are done at 6 minutes, 40 seconds. Fantastic work, guys. As you can see, 7-minute summaries are not meant to get anything of real value into your head. It's just kind of meant to give you a layout of the chapter. And as you saw, the chapter is pretty quick. Lots of reading that I skipped over, but the reading is probably going to be interesting now that we know the whole essence of the chapter. We got some problems. Problem 10, 11. How many problems do we have here? Ooh, several pages of problems. And then we go to chapter 2. So I think in the next videos, I'm going to try to go through some of these problems. I'm going to try to read some of this stuff a bit more in depth. And then we're going to do a 7-minute summary of chapter 2, 3, 4, 5, 6, all of them. Thank you guys for watching. Let me know if you have any comments or questions about what we're doing here. If you don't like the 7-minute summaries, let me know as well. And I will see you guys in the next video. Peace.